Hello everyone and welcome back to the TFK Deep Learning series, episode 1.3, Getting Started with Keras. So first of all, I would like to take this video or this opportunity to really thank and salute Mr. Frank Collett, so who created Keras, and it's really awesome, like one of the best library, and it's because of this library like I was able to learn so many deep learning networks and the concepts because it's very easy. And he is a Google researcher, and he does a lot of other tutorials on Keras and other deep learning models and all that. So yeah, thanks a lot. Yeah. So in this video, we are going to look what Keras is and how we are going to how we can install Keras, how we can switch between different backends, and how we can define the neural network model through sequential model or through functional API. And then we'll also look into different models supported in Keras and different functionality and features of Keras. But before that, let's have a recap of what we discussed last video. We discussed about TensorFlow. It's an open source deep learning library from Google, and the data here flows in form of tensors, and hence its name was TensorFlow. And we have to define anything, we define in form of graph called data flow graph, and then we execute our different computations in defining graph in one session. And then we also discuss about variables, placeholders, and how we can use them. Then we discuss about installing TensorFlow, and also I have a video of how to install TensorFlow in Keras. And then we wrote our first program in TensorFlow. It was simple addition operation, and we see how we can define the graph and how we can execute the graph in a session. And then we also discussed about TensorBoard, which is a visualization tool that comes with TensorBoard. And with this, you can visualize your graph, your operations, and there are other features of TensorBoard which we didn't discuss. We'll discuss later in the video series, but we just had an introduction of the TensorBoard. So I guess pretty much that's from recap, and let's see what we have in this episode. So first, uh, you can go to this link and you can go and have a look at different deep learning libraries comparison, and it has given all the libraries and other features comparing like CUDA support, whether it is RNN, CNN, which what is the back end or what is the front end in which it's written, and etc etc. So you can go and have a look at it to have a comparison. And yeah, so let's get started. So, Keras is a high-level neural network API, which is written in Python, and it's capable of running on three backends. It's CNTK, TensorFlow, and Theano. So it was developed with a focus on enabling fast experimentation. Being able to go from idea to result with the least possible delay is the key to doing good research. And very true it is. This library helps you to go directly from ideas to research. It's very easy to experiment different networks and models with this library. And why it is because of this following qualities: it allows for easy and fast prototyping through features like friendliness, modularity, extensibility. It supports both convolution neural network and recurrent neural network, and even combination of two. For example, in case of VQA model or image captioning, you can combine both these models, and it runs seamlessly on both CPUs and GPUs. And it is really very modular. The different functionalities of neural network, like different neural network layers, cost function, regularization, activation functions, they come all in standalone modules, and you can just import those modules and you can use them to create like any model from scratch. And it is very easy, it is easily extensible, and it is compatible with Python 2.7 to 3.6. So good news for Python people, it works with Python. And the easiest way actually, to get your Python TensorFlow through this three-step. First, you install Anaconda. It provides you a Python environment and its related library environment, and you can install any libraries through in the environment very easily through pip and conda package manager. And then you install TensorFlow, and then on top of it you install Keras. So let's see how we can install Keras. It's not with TensorFlow, it's yeah, Keras, but we anyhow will need TensorFlow for that. Before installing Keras, you have to install one of its backend. either TensorFlow, Theano, or CNTK. But they have they have recommended TensorFlow because it's the default backend for Keras, and it's really very popular and powerful. And practically, I don't know much about CNTK. I have worked in TensorFlow and Theano. So for installing Theano, you can simply install with pip package manager, pip install Theano, but you have to install this mingw libpython for Theano. It provides, I guess, G++, and then you can install Theano also through the GitHub. Then on top of it, you can install Keras, pip install Keras, or pip install this one. And then for installing TensorFlow, you can install it through pip using, this is for the CPU version and this is for the GPU version. And one best way is, if you have Anaconda, then you create a virtual environment, or if you don't want to, you need not. And this is for actually Windows, because in Windows, TensorFlow is supported for Python 3.5 and above. So you can create a virtual environment with Python 3.5, and then you can install the CPU version or the GPU version, which one you want. And then on top of it, you can install Keras similarly, like this way. Pip install Keras, and this is some other way you can install it. So one easiest way is through using conda forge if you have Anaconda installed in it. So you can do conda install -c conda forge library name, and for example, this library name could be anything like TensorFlow or Keras, and you can type this command and you can install it. And this is one an Anaconda prompt snippet where I installed TensorFlow using this command, conda install -c conda forge TensorFlow. So once you have installed TensorFlow and Keras, when you import Keras, it will give its backend. If you're using Theano, it will say using Theano. If TensorFlow, it says using TensorFlow backend. Yeah, one information is, the development of Theano has stopped, and it is from the tweet of Frank Collett again, and it was in September, and it says will stop after release of version 1.0. So it's better we use TensorFlow. Anyhow, it's really powerful. So I have a video on installing this TensorFlow and Keras I did earlier, and you can get it in my channel, or it's better I'll provide the link in the description below, and you can go and have a look at it. Okay, so let's see how we can switch between different backends. So if you go to your home directory, there will be a directory named .keras, and inside the directory there will be a file named keras.json. If you open that file, you by default you will get image data format as channel last, and backend is TensorFlow. As I told you earlier, the default one is the TensorFlow, the default backend. But if you have installed Theano and you want to switch to Theano backend, then you can change the image data format to channel first and the backend to Theano. There is also a different way of doing by importing the backend, but this is one of the easiest way. So in neural network, you can in Keras actually you can define the neural network model through two different way. One is through sequential model, and another is through the functional API. So let's first have a look at the sequential model. So what exactly is sequential model? So sequential model, as the name sequential suggests, the neural network model as linear stack of layers, either from left to right or from top to bottom, whichever you want to visualize. So it simply means we are stacking in sequence. Okay. So let's have a look through this example. So as I discussed that Keras, all the different functionality have standalone modules. So you can import the sequential model from keras.models. Then you can separately import the layers from keras.layers, import dense and activation. So this code I am explaining with the assumption that you have some idea of neural network, uh, yeah, so that you understand what that means. And if you don't know anything about neural network and all, then or you just try to understand its structure, how uh, how keras provide this functionality or structure to add on different layers. But if you know it, it's well and good, you'll understand it better. And anyhow, so I'll be doing videos in late in the series for all these neural networks, CNN, and implementing them with both TensorFlow and Keras. Okay, so coming back, so you can define the layers in one list, for example. So first is a dense layer or with 32 units, and its input coming to that layer is of shape 784. So it's a 784 dimensional vector. And then we have activation function. Then we have dense layer, and again activation softmax. And then you simply give model equal to sequential of layers, and it will create a model for you, a sequential model. Or the more intuitive way is you import the modules and then you declare this model equal to sequential, and you simply do an add function. So model dot add dense 32, its input to the network being 784 dimensional vector, then model dot add activation, then model dot add dense, and you keep on adding model dot add activation softmax. So this will create a linear stack of layers. So one important thing is you have to specify the input, and we specify the input only when we define the first, when we add the first layer. So if you see model equal to sequential, we give model dot add dense. So the first layer is of 32 unit, and the input shape that's coming to this neural network model is 784 dimensional vector. And you can give input in this way also, either like input shape equal to 784 comma, or if it is a one dimensional vector, or input dimension equal to 784. So input shape is basically a tuple of integers, and if you have suppose for example image as input, then your input shape will be number of rows, number of columns, and number of channels, and it will be in this format. Okay, so once you have defined the model, there's the important thing of compiling the model. So how you can compile the model? So you can compile the model by defining three functionalities. So model.compile, you have to give optimizer. So what optimization you want to use, either gradient descent or RMS prop or ADA delta or anything. And then you have to give the cost function or the objective function or loss function, whatever you say. What loss function will be used to to measure how well it is doing, how well the neural network is performing. So for binary classification problem, loss can be binary cross entropy, and then matrix is accuracy, just to monitor the network, how well it's performing, how its accuracy is improving. So if it is a multi-class problem, then your loss can be categorical cross entropy, and if you are working on regression problem, then loss can be mean square error. And also you can define some custom metrics and you can add it during compilation. So for example, you import your backend sk, and you want to compute the mean values of your predicted values and the true value, and so you define this function and you can add it here while compiling the model. Okay, so once you have compiled the model, you need to train it. So first step is that you have the data. Okay, once you have data, you define the model here. So model sequential, and this is the data. This is just a random data, and it's a problem of two class binary classification. So you add the dense layer, you give activation for this dense layer and the input dimension, and then you add another dense layer, which is the output layer, and then we compile the model using giving loss function optimizer matrix. And then for training, we simply use model.fit this training data and the labels, and then we give number of iterations and what is the batch size we are going to use. Once you have trained the model, then you can evaluate the performance of model on different data, like for example test data. And then also you can predict what is the output the model give for a test example with this command of model.predict. Okay, so it gives whole lot of features, and this linear stacking of layers you can do to define any different kind of models. Like if you want to define a multi-layer perceptron, you can do this. So model sequential, add dense layer, activation dense activation, and so on, compile it, train it. And you can also do convolution neural network by adding, instead of dense layer, the convolution layer. And yeah, here and in every of this model, you will see that I'm giving the input shape in the first layer which I add. Okay, and then you add convolution, you can add max pooling, dropout, and then even for LSTM you can give by adding LSTM layer, and again you have to give the input shape LSTM layer. So you can see Keras give you all this functionality of creating your different model like MLP, CNN, or RNN. So we talked about a sequential model. Now let's look what functional, how we can define the same model like convolution neural network, recurrent neural network, or MLP through functional API. Okay, so Keras functional API is actually used for defining complex models which will be having some multiple outputs, multiple inputs, or some multi-model networks or any such things. So in this functional API, what will be there, like each layer will be treated as, each layer will be having input in form of tensor, and it will return output as a tensor. Okay, and so, and this layer which takes input as tensor and returns output as tensor, these layers can be used to define this model. okay, neural network model, and this model is actually written with capital M. So, and this functional API model which we created through this, it can be trained similar to the sequential model by using simply model.fit. So first, let me just go once again what tensor is. So tensor is a n-dimensional array. So if it's a zero-dimensional tensor, it's a scalar. If it's one-dimensional tensor, it's a vector or a line. If it's two-dimensional tensor, it's an image. And if it's three-dimensional tensor, it's a cube. So it can take any tensor. Okay. So let's see, for example, this how we can define a neural network model with a functional API. So we will import the input, the dense, and then we'll import this functional API model. So we'll first define the input here, and uh, then we'll define the next layer as x equal to dense 64 activation, and to this layer the input, the input to this layer will be the previous layer. Okay, and this input will be some form of tensor, it will go here, and this x again output will be a tensor. So this will then go and feed here, and will define the next layer. Okay, and then the final layer, suppose its name is prediction, then this layer, the previous layer, will go and feed it as an input to this layer. So you can see this all x is a tensor, so tensor is going in and a tensor is coming out. And you'll see how we can create multiple input model or multiple output model with this. So once you have defined your layers, then we call this model, and we give input as this input, and the output as this final layer, which is the prediction. And then we compile this model. This should be actually in the next line, model.compile, as we did for sequential model using optimizer, loss, matrix, and then we simply train it. It's similar to that, just the way we define the model, it's different, little different. Instead of adding, we just feed it in form of tensor. Okay, so we can call this model functional API just like an individual layer. Okay, and when you are calling the model, you are not just reusing the architecture of the model, you are also reusing its weight. So let me explain how we are doing that. So in the previous slide, we saw that we defined a model here, which model equal to model input, and its output was prediction, which was a uh, 10 units dense layer. So we can create this using x as input, y is model of x. So this will be returning 10 way, it will take input as 784 dimensional vector, and will give output as 10 dimensional vector. Okay, so suppose you want to import time distributed layer, where the input will have sequence of vectors. So this was just one vector 784. Now we want to have a sequence of 20 sequence of such 784 dimensional vectors. So we can define the input sequence as input shape of 20 comma 784. So each time step has a vector dimension of 784, and there are 20 such time steps. So we can do this by defining this as time distributed model. So this model is the model which we defined in the previous slide, this one, and the input we'll be giving to this now is this input sequence, okay, instead of this input. So what this does, it will apply our previous model to every time step in the input sequence. So the output of the previous model was a 10-way softmax, and the output of this layer will be a sequence of 20 vectors, and each of this sequence will be having a vector of size 10. Okay, so you just see how we can utilize the previous model we defined for a single unit of 784 vector to some time distributed model, where it takes a sequence of input, and it gives a sequence of output. So this is really very powerful, and this is one graph example showing another functionality of this functional API. So you have this input layer, you have this embedding layer, and you can have multiple input. So you can simply we can call any layer directly, we can utilize it. So we these two layers, this was the output from this layer, then we add another layer, and this came input to this layer, and then we can get output from this layer, and this can go somewhere, we can use this output, or we can also add some other layer. So you can see all type of complex models we can define using this functional API. So that was just for a fully connected network, and this is one example showing convolution network in this functional API. So you define the input shape, you define the convolution layer and we give the input to it, and then this layer, we give this layer as input to this next layer, and we define this as a convolution layer. Then we give this x as input to this next layer, which is again x, and then we take output as flattening of this x. And when we are defining this model using this model functional API, it will just give the input, which is this much, this one digit input, and the output, which is this one. So we can give, actually we can access any of these layers. So if we name it separate differently, like x1, x2, x3, then we could have even access x from here directly instead of accessing out. Okay. Yeah. And not only this, so you can also do sorts of concatenation and all that. So two different outputs you can concatenate into one, and then you can define those models. So this is a model which is taking multiple input and one output. So this two input, we concatenated it, and then we are taking this output as output. So basically I just wanted to discuss that using this functional API you can do all this complex operation and complex model definition. So if you don't understand all, no need to worry. So as we look into different models in later videos of the series, this will make more sense. This video I just wanted to showcase the power of Keras. So basically there are two problems in supervised learning. One is regression problem and one is classification problem. So to revise or just to refresh it, regression problem is a problem where we predict some real number of values. So like predicting house prices, so it will be some real number, how many $1,000, or predicting the temperature 75 degree, based on temperature how many ounces of water you want to consume, like 2 ounces, 3 ounces, 50 ounces. And then in image processing, or sorry, in computer vision, for example, in object recognition or object detection, when you want to predict the bounding box, when you want to localize where this stop sign is, then you have to give real value of where the location is. So there also we use this regression thing. And classification is simply you have two or multiple classes and you want to learn a model which classifies them. You show them an image, it says whether it's cat or dog or anything else. So it's basically categorizing. And this Keras support binary classification, multi class classification using this loss functions, and it support this regression problem. And you can define this loss like MSE. So I just want to tell this, there are basically two major problems, and Keras support all of this. So you can whatever your problem or model is, you can use Keras to do it. And it supports MLP, like adding dense layer, adding convolution layer, adding LSTM layers, recurrent layers, and problems like classification, and problems like this one where you have to recognize as well as localize. So this all model can be implemented in Keras. Or complex model where we have a CNN and a LSTM. So CNN, we are feeding, we are getting image features through CNN, and then we are getting caption through the LSTM. So this is a problem of image captioning which uses both CNN and LSTM, and it can be built with Keras. So another is a VQA model. So you have an image and you ask a question, and then the model need to answer based on the question and the image. So we have an input coming from CNN and LSTM, and then we are giving one output from LSTM, or any model you can design it. Just so I just wanted to show you all these different examples, and this all can be implemented very easily in Keras. Then in Keras, transfer learning means there is option of freezing different layers, and I have done a video on transfer learning with VGG and ResNet, and you can train only the last few layers. Or yeah, you can like freeze up to any layers and train any layers. So these all options are there in Keras, so you can try all these functionalities of Keras. Similarly in ResNet. And Mr. F. Collett, the creator of Keras, he has also given all the deep learning models like Inception, ResNet, MobileNet, or VGGNet, and along with their weights. So in the releases, you can get also their weights, and you can utilize those pre-trained models for your problems. Okay, so Keras has actually all this functionality. So we discussed about we should have data, we define model, we compile the model, we train it, and then we evaluate it, we test it. So these are the general functionality. But Keras also has other functionalities, like you can have use this model.summary, and you can get a full summary of your entire network. What is the input, what is the output, whether it's convolution layer, what is its output shape, and how many parameters it has. So it's really good to visualize, and you can get total parameters also, and then you can get a configuration of this model, like which regularizer you're using, how many rows, columns, what is the activation function, like here the activation is relu, what is the name of this layer, and this is the full model. You can get the configuration for individual layers also through this. Okay, and then yeah, this was for getting configuration of an individual layer. Okay, so model dot layers of input shape is here. Okay, so this was model dot layers of 0 dot get config, giving the layer configuration, and also you can get the input shape separately. No, if you don't want to get through summary, by using this it will give you the input shape, and then you can have also the output shape of this layer, and then you can also check whether that layer is trainable or not. If you have if you want to freeze it, you can freeze it so it won't train, or if you don't freeze it, then it will train, and you can use all these commands to visualize all this. And then also you can get weights, which means parameters of different layer. So I am getting the 0th layer parameters. So these are the parameters, these are the filter values which we see in convolution neural network. This is example from convolution neural network. And you can see the shape of this weights. So it will be number of filters, and the shape of each filter is 3 by 3 or something. So I'm not concentrating more on the theoretical concept, but just I'm telling you what are all functions are there in Keras. Then there is a function of Keras callback. So in callback, you can get features in between features during the training. So you can do early stopping, or by monitoring some example like validation loss, and if it's not improving, then you do stopping before even it completes the training for entire iteration. And then you can save it, the logs, using CSV log, and then you can even save the model weights by providing some checkpoints, model check. Yeah, so you see these are Keras callback functionality. And yeah, this you can go and have a look at. It's actually, Keras is very well documented, so you can go online and read the documents for different functionality which you want. And yeah, and also you can plot the graphs, and like this is the blue one is the training loss, and this is the validation loss. You can see how well your network is doing in different iteration step, and you can apply early stopping or any such things. Then you can obviously do a model checkpoint, where you can also save intermediate like weights or models during the intermediate training. And then we can visualize the intermediate layer output of CNN. Like, this is the code. I will not go into the code, I just wanted to show you, like, so suppose this was the input layer here, and this is the some of the feature map of intermediate layer. So you can visualize it, and you can see, like, whether your network is learning some features or not. So Keras give all this functionality. And then coming to one final point, that we can save the model in weights. So when you train the model, the parameters gets trained, and once training is complete, we have to save it so that we can deploy it somewhere, or you can use it in future. So you can do that with using this command. So there are 2 3 ways to save it. So one is, if you want to save the model, you can save it in JSON structure, and then you can save the weights in .h5. Okay, and then when you have to load this model, you load this JSON file, and then you load this weight using loaded model dot load weights and giving the weight name. Okay, and another way is simply instead of saving model and weight separately, you can directly save the model along with weight in this format, model dot save model dot hdf5. It will save both model and weights together, and then you can load this model using this, or this two-way: save the model, save the weights, load the model, load the weights, or you do both together and load the both together. Okay, so this is a way you can save your trained models and utilize it later. Okay, and these were some of the links I wanted to tell you, like, if you want to go and read more about Keras, and more how you can implement different modules in Keras. This is one blog which I found useful. So I'll give a link of this. It's kdnuggets.com, 7 steps deep learning Keras. And then another is Keras cheat sheet, or different functionality of Keras given in one cheat sheet. And also you can go and have a look at this datacamp community thing, and I'll give a link for the cheat sheet also. So this is actually the cheat sheet. So they have given Keras basic example, how you can do pre-processing, how you can define sequential model, how you can do your MLP, how you can do regression, how you can define convolution layer, how you can define regression layer, how you can do training, and all the basic functionality are there in just one PDF file. And I'll give the link below. And you can also have this look at this same from the data camp community tutorials on deep learning with Keras. And then there is another blog by Mr. Jason, and he also explained very well Keras step by step, so you can have a look at this. And then there is a book, Deep Learning with Python, by the creator of Kera himself. So yeah, it's really, it will be, I haven't read it, but I'm pretty sure it'll be a very great book. You can go and purchase this. So, and then this Keras 2 was introduced in this year March 14. And one thing I wanted to highlight was TensorFlow integration. So before TensorFlow was just backend, now the Keras API will now become available directly as part of TensorFlow, starting with TensorFlow 1.2. So what it is like, in TensorFlow, you'll have a module as tf.Keras. So I told you even in previous video that we'll try to explore this. So I'll not make a separate video explaining all this, because this is just a module. You can just simply import and use different functionality. When we do a different network like linear regression, logistic regression, or CNN and anything, then we can just have a look how we can utilize this. So you can use TensorFlow as backend, and this Keras module as API, like tf.keras.activation. Rather than using TensorFlow activation, you can use Keras API in the TensorFlow, and you can make use of this powerful API structure. Okay. Okay. So yeah, this was about the Keras 2 API on top of TensorFlow. And now let's code out. So I have whatever we discussed, I have small code for it in the Jupyter notebook. And this is for the sequential model. And let me first clear the old outputs. So yeah, let's clear it out. Okay, now let's import the models or the modules which we need from the Keras. And it says using TensorFlow backend. And then we are going to randomly generate data, and it is a problem of binary classification whether the data belongs to class 0 or class 1. So we have data train 1000 samples, each sample is 100 dimensional, and labels we have, it will be, since there are 1000 samples, there will be 1000 labels, one for each data, and they will belong to two classes, either 0 or 1. Then I have defined a test data where there are 200 samples and obviously 200 test labels belonging to either 0 and 1. So let me run this, and you can print and just have a look at this. Is so you can see data train, one of the sample, it has 100 values, its label is 0, and data test, it has some random values and its label is also 0. Okay, now let's define the model. So we'll define a sequential model, and we'll add a dense layer of 32 unit activation ReLU, and its input is, as we saw, it's 100 dimensional. And then the final layer will be a 1 unit, and its activation is sigmoid. So let's run this. And now let's compile the model with optimizer RMS prop, loss binary cross entropy, since it's a binary classification problem, and matrix accuracy. So, and you can run model.summary to get a summary of the model. So it says, the first layer is a dense layer of 32 units, and the second layer or the last layer is a dense layer of 1 unit, and this many parameters are to be trained here, and these are the total parameters or trainable parameters. And then we can train it very simple using model.fit data train labels train, and we'll train it for 100 iteration with a batch size of 32. And you will see that it's training, and as training you can see the accuracy in 40 POC is 78%, and when it reach 100 it's 97, and loss is reducing. So it's training pretty well. Now we can evaluate the performance of this trained model on our test data. So let's run and see. So we can see that with this trained model on the test data, we can get 94% accuracy. So it's pretty good model for this random data. And you can, predict the output of any single test data. So suppose we have taken a test data 6 sample in that data test, and it will be predicting the probability. So let's run this. So you see its predicted probability is 0.94, which is 94% that it belongs to class 1. So the predicted label become class 1 and its true label was class 1. So the model is quite good, it's predicting what the true label is. And then you can save the model using model.save in this name, my model sequential.hd5, and the model will get saved in this format, and you can load it using load model as I talked in the slides. So this was using sequential model. The same thing we can do it using Keras functional API. So this is another Python notebook, and let me again clear the output for it and restart the kernel. So here we'll be importing the input, the dense, and this functional API model. So let's import this, and then again this is the same data set. So we are having 1000 trained samples, and each sample is of 100 dimensional vector. So each input is 100 dimensional vector, and the output label is 0 and 1, and there are 1000 trained data and 200 test data. Let's run this. So here we are defining this model by giving this inputs as input shape is 100, and then we are giving x dense 32 activation ReLU, and to it we are feeding the inputs using this tensor inputs as tensor, and this x will be another tensor which we are feeding to another dense layer of one neural network unit, and activation is sigmoid, and x is its input. So let's run this, and then you can define this model using this model capital M, giving input, and the output is our the last layer which we define, which is the prediction. And after this, everything is same as in sequential model. We'll compile the model using optimizer, a loss, a binary cross entropy, since this is a binary classification problem. And similarly you can uh, print model.summary, and you will see the same thing. It's 100 unit in the input, 32 unit, 100 the input, it's 100 dimensional. Then the first layer is 32 unit, second layer is one unit of neuron. Now you can train it in the similar way, model.fit, and it will start training for 100 iterations, and you will see the same thing as as we increase the iteration. So if you see, it started with 47% and loss is 0.71, but as we reach 100 we get a loss of 0.19 and accuracy of 98% on the training data. So once the model is trained, let's evaluate this on test data, and let's see what it gives. So it gives 93% accuracy on this data. So it's pretty good model again, and we can again predict the output value of a single test data or any new value. So I'm just testing out the sixth value or the sixth test sample, and I will also predict the true value or true level of the sixth sample. And let's see. So the model, as I told you, it will predict the probability of getting one. So it's 0.94%. That's and I've put a threshold of 0.5. So if it's greater than 0.5, we are taking that label as one, and the true level is also one. So if it was less than 0.5, the label would have been 0. Since it's a binary classification problem, you will have just one unit predicting the probability of 1, and for 0 it will be 1 minus the probability of 1. And if it was a multi-class classification, then you'd be getting the probability of each class. Okay, and this is just to try out, get started with Keras, and there are a lot of tutorials there. You can try out the true model. This is just a dummy model. So, and you can save it using this command. Okay, so I'll provide the link of GitHub where I'll put this to notebooks. And these are just dummy network, just to get your hands on with the Keras functionality. There are a lot of good examples you can try out. So I guess pretty much from here, and in the next episode we will be understanding linear regression and gradient descent, and then we'll implement this with TensorFlow and with Keras. Okay, so I guess pretty much that's all from this video. I hope you like the video, and if you have any queries you can comment below, and you can subscribe, and if you want to support me you can support me here. And that's all. Thank you for watching, and till then, keep learning. Bye.